Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 2 from section 1-2 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to solve consecutive integer problems. Oh my Lanta, we better figure out what that means, right? So when we talk about consecutive, that means that it's going in order. Okay, so for example, the numbers 1, 2, and 3 are consecutive. All right. 11, 12, 13, those are consecutive. So when we're talking about consecutive integers, we're talking about whole number increments, which are in order. So if I read this problem, it says, the sum of 3 consecutive integers is 132. What are the 3 integers? So I have 3 values. When I have a sum, I'm doing some kind of addition, right? So I have 3 values being added together that adds up to make 132. Now here's the challenging part, is trying to find a way to describe these integers. So when you think about like 1, 2, and 3, or 20, 21, 22, realize that we're going to keep the first integer as the letter x. And to get to the next integer, so from 1 to 2, I would take this value and add 1 to it, wouldn't I? To get the next number in the line, I would need to add 2 to it because it would jump on a number line by 2 hops. So here's the first number, here's the second number, and here's the third number. And if I add those together, I get 132. So the first thing that I tend to do with these problems is I collect my like terms. So I have an x here, an x here, and an x here. So altogether, I have 3x. I also have a plus 1 and a plus 2. Together, that's adding 3 to this problem. So now I have an expression, 3x plus 3, that will get me the value of x if I solve for it. So it'll get me my first counting number. And then I could get the other 2 values from there. So looking at what's happening to x, I see that x is being multiplied by 3, and that x is being added by 3. So if you consider PEMDAS, and remember when we're solving for x, we're going backwards through PEMDAS, I need to deal with my addition and subtraction before I deal with multiplication and division. So this plus 3 has gots to go. To do that, I'm subtracting 3 from each side because subtraction is the opposite of division. So on the left-hand side, the plus 3 and minus 3 cancel out, and I'm left with 3x. And on the right-hand side, 132 minus 3 is 129. Now remember, if you have a number and a letter that are squished up together like that, they are multiplying. So to get rid of the multiplication of 3, I need to divide 3 from each side of the equation. Alright, and when I do that, I get x is equal to 43. Now remember, this is asking for 3 values, isn't it? It's asking for the first number, which was x. And then it's asking me for 2 other numbers in the sequence after 43. So if I'm doing consecutive integers, the next one would be 44, and the next one would be 45. Now this try it gets a little spicy, a little caliente. Notice that it says consecutive odd integers. So for example, let's think about odd integers. I have 1. The next odd integer is 3. The next odd integer is 5. Then 7. Then 9. Then 11. And if I think about these, somewhere along the line, because this thing goes on for forever, 3 of these in a row add up to 57. Okay, so I have some number plus some number plus some number is equal to 57. Now the first value itself is x, we know that. But how do I describe these other two blanks? I can't do it like I did on the last one, because if I add 1 to 1, for example, I would get 2, so it's not quite hopping. So if you think about a number line, to go from odd to odd, I'm skipping an even. So here I would have to add 2, or add 2, or add 2. So on here, my consecutive odd integer would be the initial value plus 2. And then to get the next odd, I'd have to add another 2. So I get 2 for this one, and 2 to get here, which puts me at x plus 4. The rest of it all works the same. So first I'm going to collect my like terms. I have an x, and an x, which makes 3x. And if I look at my constants, I have 2 and 4, which together makes a plus 6. So now I look at this. I have multiplication from the 3 and addition from the 6. So if I'm working backwards through PEMDAS, I have to counteract that addition first. Now the opposite of adding 6 is subtracting 6, which I'm doing here. The left-hand side of my equation, the plus 6 and minus 6 cancel out. And on the right-hand side, 57 minus 6 is 51. So now I am left with 3 times x sitting here. And so to undo that multiplication, my inverse operation is division. So I divide both sides of the equal sign by 3. And remember, if you do it to one side of the equal sign, you have to do it to the other. So notice that these operations are coming in pairs. So when I divide by 3, 51 divided by 3 is 17. So in terms of my 3 consecutive odd numbers, I'm starting at 17, the next odd is 19, and the next odd is 21. And I could take a calculator and check that. I could do 17 plus 19 plus 21, and I should get 57. So there we have it. That's how to solve consecutive integer problems. Until next time.